Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem solve. Y double dash minus 2y dash plus y equal to x e power x log x for x greater than 0, or d square minus 2d plus 1 into y equal to x e power x log x using variation of parameters method. We are given a differential equation of order 2. Given differential equation, y double dash minus 2y dash plus y equal to x e power x log x. Consider as equation 1. We can write y double dash as d square y by dx square minus 2 into dy by dx. Write y dash as dy by dx plus y equal to x e power x log x. Now we can write d square y by dx square as capital D square y using the differential operator d, minus 2 into write dy by dx as capital dy plus y equal to x e power x log x. Now take y common from all the three terms of LHS. We'll get d square minus 2d plus 1 into y equal to x e power x log x, which is considered as equation 2. The equation 1 in operator form is the equation 2, right? In operator form, say f of d into y equal to some function of x, where f of d is d square minus 2d plus 1 and r of x is x e power x log x. Now we'll find the solution to our problem equation 1 and 2 using y equals to yc plus yp, that is the general solution using y equal to yc plus yp. We'll find using yc using auxiliary equation, and later using yc we'll find yp and some formula. Okay, we'll find yp using yc and two formulae, right? Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 1, right? Let's replace the differential operator by m so that we'll get f of m equal to m square minus 2m plus 1. Now the auxiliary equation becomes m square minus 2m plus 1 equals to 0. Now we need to find roots to this equation. We can write m square minus 2m plus 1 as m minus 1 whole square. From this we'll get m minus 1 into m minus 1 equals to 0. Now equate each factor to 0. When m minus 1 equals to 0, we'll get m equal to 1. Since m minus 1 is repeating twice, so we'll get m equal to 1, 1. The roots are real and equal. Repeated roots otherwise. We know that when two roots say m1 and m2 are real and equal, then yc looks like c1 plus c2x into e power m1 x, right? Now coming to our complementary function. Yc equals to c1 plus c2x into e power equal root 1 into x. This gives us c1 plus c2x into e power x, or c1 e power x plus c2 x e power x. So we got yc now. Let's find yp. Let yp equal to, now replace the constants of parameters with functions of x, a and b. We'll get yp equal to a e power x plus b x e power x, where a and b are functions of x. Now you can compare yc with c1u plus c2v, or yp with au plus bv. Then you'll get u equal to e power x v equal to x e power x, right? Equal to e power x, v equal to x e power x, and we'll find a b using some formula. A is given by integral minus v into r of x by uv1 minus vu1 into dx, and b is given by integral u into r of x by uv1 minus vu1 into dx. If you notice, we are having uv1 minus vu1 in both the formulas, so we'll begin with uv1 minus vu1 and later we'll find a, b, yp and find with the general solution using y equal to yc plus yp. v1 is nothing but derivative of v with respect to x minus v into u1 is nothing but derivative of u with respect to x. This gives us u e power x into derivative of v with respect to x minus v into derivative of u with respect to x is equals to e power x into, here we are going to apply uv whole dash formula, which is u dash v plus v dash u. This gives us derivative of x with respect to x into e power x plus derivative of x into derivative of e power x with respect to x minus x e power x into derivative of e power x with respect to x is e power x. This gives us e power x of derivative of x with respect to x is 1 into e power x plus x into derivative of e power x with respect to x is e power x minus x e power x e power x. This is equals to e power x of 1 into e power x is e power x plus x e power x minus x e power x into e power x. This gives us e power x into e power x plus x e power x minus x e power x e power x. E power x into e power x is e power 2x, right? Or e power x whole square, which is e power 2x. Now replace e power x into e power x with e power 2x. We'll get e power 2x plus x into e power 2x minus x e power 2x. Here minus x e power 2x plus x e power 2x gets cancelled and we'll get e power 2x. Therefore, uv1 minus vu1 is e power 2x. Now coming to A is given by integral minus v into r of x by uv1 minus v1 into dx. This gives us integral minus v x e power x into r of x is x e power x log x by uv1 minus v1 is e power 2x into dx. This equals to minus integral x into x square e power x into e power x e power 2x log x by e power 2x. Here e power 2x gets cancelled, we'll get minus integral x square log x dx. Let's now evaluate integral x square log x dx using integration by parts formula. Integral u dv equal to uv minus integral v du. Here the integrand is of the form product of logarithmic function and polynomial function. Consider the logarithmic function as u and the remaining part x square dx as dv. Differentiate on both sides with respect to x. We'll get derivative of u with respect to x equals to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx, right? Here integrate on both sides. We'll get v equal to integral x square dx is x cube by 3, right? Now substitute in this formula, we'll get integral u dv log x into dv x square dx equal to u into v. U is log x into v is x cube by 3 minus integral v du v into du 1 by x dx, right? This gives us integral x square log x dx equal to x cube log x by 3 minus 1 by 3 into, if 1x gets cancelled, we'll get x square dx. This gives us x cube log x by 3 minus 1 by 3 into integral x square dx is x cube by 3, which gives us x cube log x by 3 minus x cube by 3 3s are 9. It's 3. Okay. Therefore, integral x square log x dx equals to x cube log x by 3 minus x cube by 9. Since integral x square log x dx is x cube log x by 3 minus x cube by 9. This gives us minus of x cube log x by 3 minus x cube by 9, which gives us minus x cube log x by 3 minus into minus plus x cube by 9, right? Therefore, a equal to minus x cube log x by 3 plus x cube by 9. B is given by integral u into r of x by uv1 minus v1 into dx. This gives us u e power x into r of x is x e power x log x by uv1 minus v1 is e power 2x into dx. This gives us x into e power x into e power x is e power 2x log x by e power 2x into dx. Here e power 2x gets cancelled. This is equals to integral x log x dx. Since let's evaluate integral x log x dx. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du, right? Here the integrand is of the product of logarithmic function into polynomial function, right? Product of logarithmic and polynomial function. We'll take the logarithmic function as u and the remaining part x dx as dv, right? U equal to log x and dv equal to x dx. Differentiate on both sides with respect to x. We'll get derivative of u with respect to x equals to derivative of log x with respect to x is 1 by x. This gives us du equal to 1 by x dx. Here integrate on both sides to find b. We'll get b equal to x square by 2. Now substitute in the formula. We'll get integral u log x into dv x dx equal to uv log x into v is x square by 2 minus integral v x square by 2 into du 1 by x dx, right? Which gives us x log x dx equal to x square log x by 2 minus 1 by 2 into, if 1x gets cancelled, we'll get integral x dx, which gives us x square log x by 2 minus 1 by 2 into integral x dx is x square by 2, which gives us x square log x by 2 minus x square by 2 2s are 4, right? Therefore, integral x log x dx equals to x square log x by 2 minus x square by 4. We know that integral x log x dx equals to x square log x by 2 minus x square by 4. So we'll get x square log x by 2 minus x square by 4. Therefore, b equal to x square log x by 2 minus x square by 4. We got a and b. Let's now find yp. We'll find yp using a e power x plus b x e power x. Now substitute a and b, where a is minus x cube log x by 3 plus x cube by 9 into e power x plus b x square log x by 2 minus x square by 4 into x e power x. This gives us minus x cube e power x log x by 3 plus x e power x by 9 plus x square into x is x cube. We'll get x cube e power x log x by 2 minus x square into x is x cube e power x by 4. Now take x cube e power x log x common from these two terms. We'll get minus 1 by 3 plus 1 by 2. And take x cube e power x common from these two terms. We'll get x cube e power x of 1 by 9 minus 1 by 4. Minus 1 by 3 plus 1 by 2 is minus 2 plus 3 by 2, which is 1 by, minus 2 plus 3 by 6, which is 1 by 6. And 1 by 9 minus 1 by 4 is 4 minus 9 by 36, which is minus 5 by 36. We'll get x cube e power x log x of 1 by 6 plus x cube e power x of 1 by 9 minus 1 by 4 is minus 5 by 36. From this we'll get yp equal to x cube e power x log x by 6 minus 5 x cube e power x by 36. Right? Now take the LCM of 6 and 36. The denominator of first term we are having 6, so we need to multiply the 6 to the numerator of first term. We'll get 6 x cube e power x log x minus, in the denominator of second term we are having 36, 6 into 6 36, so we'll multiply, there's nothing to multiply with the numerator of the second term. This gives us, we can just write it as fraction. We can split the fraction as 1 by 36 into 6x cube e power x log x minus 5x cube e power x. Now take x cube e power x common from these two terms. We'll get 1 by 36 into x cube e power x of 6 log x minus 5. Therefore, yp equal to 1 by 36 x cube e power x of 6 log x minus 5. Therefore, the general solution is given by y equal to yc plus yp. We have yc and yp, let's substitute that. Yc is c1 plus c2x into e power x plus yp is 1 by 36 x cube e power x of 6 log x minus 5. Therefore, y equal to c1 plus c2x into e power x plus 1 by 36 into x cube e power x of 6 log x minus 5 is the required solution. So this is all for now. I hope you will understand. We'll see you in the next video. Until then, bye bye.